Okay, so this is the last part of that notes on sum and difference identities for trigonometry. So when we look at this one here, it says here, example 4, write each expression in simplest form and then evaluate where it's possible. Okay. So over here, this looks like it's a complicated thing, right? But if we were to simplify that, this is your alpha, and this is your beta, alpha, and beta. So if we look in our identity, where does it say tan alpha minus tan beta? That's this one right there. Okay. So this can be simplified to tan of alpha, which is pi over 2 minus pi over 3. And then we can certainly simplify that further, make it under one angle. So we're going to multiply this by 3/3. And then this we're going to multiply by 2/2. So that's going to be tan of 3 pi over 6 minus 2 pi over 6. So that's going to be tangent of pi over 6. Okay. So tangent of pi over 6. So when we have something like this, so what is the tan of pi by 6? It didn't ask us for an exact value, so what we can do is we can just figure out the value of this particular trig function, trig expression. So tan of pi by 6 would be 0.577. So the tangent is 0.577. Okay. Let's take a look at this one. None of these are special angles, but when we look at this one here, sine of 8x times cos of 3x, cos of 8x, or minus cos of 8x times sine of 3x. If we were to write that in the simplest form, what would be the simplest form of that? Well, yeah, well, that 3 times the angle, 3 times the angle, right? 3 times the angle here, 8 times the angle. So x is your angle. So what would be the simplest form of this? So this, when you think of this as your alpha, this is your beta, alpha, this is your beta.
Sine alpha minus beta.
Okay, so if you look at that, sine cos minus cos sine, sine cos minus cos sine, that's, we can simplify that as sine of alpha minus beta. So that's going to be sine of 8x minus 3x, and sine of 3x, sine of 3x, 8x minus 3x is 5x. Now, this one here, we can't evaluate this because we don't know what the x is, so that's a simplified version of it. Okay? So far so good? So sometimes it's good to expand, right? It's good to expand things. Sometimes it's just good to narrow things down, and we'll see why that is important later on. Okay, so let's take a look at example 5. Now we're getting into proving this identity. So cos of pi half, so that's your alpha, minus x, so that's your beta. We're going to prove that whatever this is, it really boils down to just sine of x, or is equivalent to sine of x. So let's do that. So in this particular case, it's good to expand it, right? It's good to expand. So cos of pi halves minus x. How can we expand that? Cos, the difference, so that's going to be cos alpha, cos beta, plus sine alpha, sine beta. So this is going to be cos pi over 2, cos x, we don't know what x is, right? Plus sine pi by 2 sine the beta, which is sine x. I should have put it more that way. Okay, now some parts of these can be simplified further, because cos of pi over 2, that's going to be 0. 0 times cos of x plus sine of pi half is 1 times sine of x. So 0 times cos of x is 0 plus sine of x. So that's a sine of x. So the left side is equal to the right side, congruent to, is equal to the right side. Okay, that's bad. That's pretty good, right? Take a look at the B. How can we expand this so that we can prove that this is true? Which one is that? Sine. Okay, so that's this one here, the difference of the angle. So sine alpha minus beta. So alpha is your pi, beta is your x. So it's going to be sine alpha, which is pi, times cos beta, which is x, minus cos alpha, which is pi again, sine beta, which is our x. So we're working on the left side because it's more complicated. Sine of pi is going to be 1. Cos of x, well, we don't know, just cos of x, minus cos of pi, which is 0, times sine of x is sine of x. So this is going to be really 0, so it's going to be cos of x. No, well, hold on.
That's not right, right?
Sine of,
Sine of pi is
sine pi of, oh, this is 0, and this is 1. Oh my goodness, I was like, uh-oh.
scared me.
Okay, let's see. Sine of, I should go pi. I'm thinking pi half. So sine of pi is 0. And then cos of pi is -1 minus -1. There you go. Almost gave me a heart attack there. Almost. Minus. I was like, uh-oh, why is it cos? Okay, good. Now that makes sense to me. Yeah? Are you okay?
Better have my circle wrong.
I thought I had my circle wrong. My brain is saying there. Okay, so example 6, we got to oh yeah. Now this one is becoming an equation. What's the difference between an equation and an expression? Because there's already an equal sign in between, right? So we're solving for x. We're solving for x. Equation. And then they said the domain is from 0 to 2 pi, not including 2 pi. So when we have this sine, cos, sine, we can simplify this using our trig identity. So which is the appropriate trig identity for this one? That's a minus, or sine of a minus b. Right? Is everybody okay with that? Right? So this identity can be simplified as sine of alpha minus beta. Yeah? Okay, so let's do that. So this becomes sine of alpha, which is 5x, minus beta, which is 3x, equals to 1. Okay, so that makes it a lot simpler. What do you think is the next step here?
Combine.
Yeah, combine, right? Simplify this inside. So this is going to be sine of 2x equals to 1. Okay. Do you remember what we did last time? Okay. So we said we're going to let theta is equals to 2x. So sine of theta is equals to 1. And then we have to look, okay, where is sine 1? What angle is sine 1? It's going to be pi over 2, pi half. Okay, so this is pi halves. Okay, now our question is not about theta, but it's about the axis. So we're going to put that back over there. So this becomes 2x equals to pi over 2. So x equals to pi 4. Okay, now we're getting into the double angle in here. We haven't quite figured out, we haven't really talked about the double angle identities yet, right? This is our double angle identities, but because we haven't talked about that yet, we had a different strategy on how to figure this out, right? So here it is. We said that this is our solution, but because this is sine of 2x, okay, that means the period of our sine function is 2 pi over 2, right? 2 pi over the b value. This is your b value here. So the period is pi radians.
Where's our b value?
The b is this one. 2 pi over b. So in this particular case, we can write our general solution in here. Our solution is, I'll just put general solution, would be pi over 4 plus pi k, where k is an element of integer. This is a general solution. But we have a specific domain. Our domain is from 0 to 2 pi. So what's our x then? Our x is pi over 4, because pi over 4 is certainly within that domain. Yeah? If we add another 1, if k is 1, that's going to be 5 pi over 4. Is everybody okay? So you get 4 fourths and then 1/4, so 5 fourths. And 5/4 is still within that domain, right? What if we go up to 2? 2, now this becomes 2 pi plus 1/4. Well, that's going to be way above, right? Because this is going to be 2 pi plus 1/4 of a pi. We're going to be over the 2 pi limit. So therefore, these are our two solutions. These are. So x are pi over 4 or 5 pi over 4. Okay. Right now, this is one strategy that we're working on. Later on, we have different kinds of strategies. Let's see this one here. Let's see if we can simplify all of these. What would be the simplified version of cos 4x times cos x plus sine 4x times sine x?
Cos alpha minus beta.
Cos alpha minus beta. Is everybody okay with that one? Because you have cos, and then a plus, cos, and a plus, sine. Okay, so this boils down to cos of 4x minus x equals to, is that 1? Yeah, it is 1. Okay, so cos of 4x minus x, that's going to be cos of 3x equals 1. What we're going to do is we're going to say let theta would be 3x first. So cos of theta is equals to 1. Where's cos of theta equal to 1? Cos, it's going to be 0 and 2 pi, right? So theta is equals to 0. Okay. So that means 3x equals to 0. So x equals to 0. Are you okay with this? So what else do we know? Because this is cos of 3x, the b is 3. That means the period must be 2 pi over b, which is 3. So period is 2 pi over b. And your b is 3. So the general solution would be, I'll start with the general solution in here. Our general solution would be 0 plus 2 pi thirds times k, where k is an element of the integer. Now, this one could be gone, right? If k is 0, let's start with that. If k is 0, so x is equals to 0. If k is 1, it's going to be 2 pi over 3. Is that 2 pi over 3 within the 2 pi limit? Yeah. Okay. Now, if k is 2, then we're going to get 4 pi over 3. So 4 pi over 3. This is 1/3, 2/3, 3/3, 4/4, 4 pi over 3, right? So 4 pi over 3, that's still there. What else? What if I do another? What about 3? If this is k is 0, k is 1, k is 2, what if k is 3? It's going to be 2 pi. Okay. Yeah, we would go for 2 pi, but they said here 2 pi is not included, so yeah. So 2 pi certainly go over here, but because there's a round brackets on 2 pi, and that doesn't really count. So these are our only solutions for that. Okay, that didn't take us long, right? That was nice. So, I gave you the first part of your questions, practice. After we did the examples 4, 5, and 6. So these are your next practice questions. It's pretty much in here. Practice. Question number 4, 5, 9, 12, 14, 15, 17. I'm getting rid of the 18. And then multiple choice 1 and 2. How's that? Okay. So certainly we got about 20 more minutes. Do take advantage of that. And then I'll be here to answer some of your questions if you have any questions and to help you.